A lot of today is really talking about the new assessments, the 4 types of assessment. Now you'll know a lot about this, but might be some gaps we can all fill in together, and there'll be bits and pieces I'll talk about how the text helps you deal with some of those things. This is the plan for today, so we'll just go through these in order. We've got about say 45 minutes, and then we'll see about questions. Okay, that's me. Listen, they just put that in there. You've seen me online with the discussion group, but the main thing, I added this last line at the bottom because they didn't have it in. I'm currently teaching physics at Moreton Bay, so I've got grade 11 and 12, but I've been teaching physics for 30 years or so. The reason I put it in, because people have said to me, the reason we like your book is because you're a practicing teacher. You're actually teaching physics and chem at the moment. Oh no, not chemistry anymore, but physics at the moment. And I actually, as I've developed the drafts or the book over the last 3 years, I've been using it with my classes. I changed over to the new order of topics, not the new syllabus, but the new order of topics. You know this, and some of this is not, well, it's a bit misleading, but I just want to run through a couple of things to make sure, we all sort of know what's going on. Now, where it's got F1A1, the data test at the top there, that has to be done sometime in grade 11, or units 1 and 2. When Oxford made up this table, I modified it, I deleted bits and pieces, but somewhere in there you're going to do a data test, somewhere between term 1 and, well, I don't know when you're changing to the unit 3 and 4. With me, I'm changing over to unit 3 here at the beginning of term 4. So in terms 1, 2 and 3, I'm doing all of unit 1 and 2. So I'm about here now, and but you'll be doing it differently. Some people, I believe, are doing the unit 1 and 2 right till the end, and a lot of people, I know, a lot of people are changing over to grade 12 or the unit 3 here for the start of term 4. So that's why this table can't sort of capture everything, but it's captured some of the main dates. I think the important one here for us is having the IA1 and 2, that's the data test and student experiment, ready for endorsement by week 6. But my school, if it's anything like you, my school has said to me, we want it 3 weeks early. They want it 4 weeks early. They wanted that at the beginning of term 3. But we said that's a bit too early. I've got mine ready because I've been working on this for a while. So my IA1 and IA2 are ready. We're all looking forward to the mock exam on the 12th of July. That's the endorsement of IA3, the research investigation. So, but it depends on when you're running your data test. I'm running my data test down here because I'm doing that gravity and motion unit here, the unit 3, topic 1, having the data test. And then I'm starting electromagnetism and that unit up here, and then I'm doing my student experiment in magnetism, electromagnetism. The tricky thing is, I suppose, when are you going to... We have to submit our IA1s and IA2s and 3s in week 7. Your school might want them a lot earlier than that because, the deputy or your curriculum coordinator or someone will want to go through all the packages like they did for verification. They wanted it 4 weeks earlier than that. But, if you're running somewhere in here, about week 3, you're hardly past relativity, and that rules out all the quantum theory and all the standard model, for your research investigation. But that's what I've had to do. They want it early, and I'm doing my quantum and standard model down here, and then I have to leave. I want to leave quite a few weeks for revision. Now, I'm trying to leave about 5 weeks for revision. That's a lot of time. But in that, of course, they're going over some of the things they've missed up here. So I don't know how you're doing it, but I mean, that's basically what we're all working to, except for the positions of the tasks. All the confirmation or the endorsement and confirmation are all sort of set. Okay, let's move on. Wrong one. You know this, you've probably seen this a million times, but Unit 1 and 2, well, that's what I'm on at the moment. I've just started linear motion, but I've had to cut, I don't know about you, but I've had to cut so much out. I've cut sound out. Can you believe that? I've cut sound out of my grade 11 course. And, you know, for 30 years I've been teaching sound, and that's gone. And I took probably a month to write that chapter. They want to allow more time for the Unit 3 and 4 stuff, so they want to start early. So that's the way it is. Okay, of course, grade 12. You've seen all this, you know all this sort of stuff. The data test and student experiment in Unit 3 and the research investigation, Unit 4. Right, this is the aim of the two books, or more than the two books, the student workbooks as well. It's this enormous period of change. Now look, Oxford put this, they called it Painpoints, and they just left it blank and they just put the 4 headings, and the publisher said to me, can you just put in some words where people will find problems? Now, the way I'm going to do this, I'm going to have a look at a couple of these, as they call them, pain points, and I'll just run through the chapters and just mention one thing about each chapter, about where you might, where you're going to find trouble, I think. For gravity in motion, depth of treatment is, to me, trying to work out something about what the syllabus means and how you're going to do problems that will be of the standard that could be in the external exam. And I'll show you a few in a minute. It's quite tricky. And I've rung up QCAA many, many times, to say, would you have this sort of question? Would you have this? Would you have this? And they answer it. I mean, they can't be too specific because they don't want to give away questions that'll be on the external exam. But they tell me the sorts of things. They unpack some of those objectives. And so that's been valuable. And the guy said to me, no one from any of the other publishers rung him up so much and asking these questions. But I thought I've got to get it sorted out, not so much for the text, but for my own teaching as well. I don't know, getting the data test endorsed. I've written a data test for the Unit 3. That'll be a part of the O book. If you get the book, it's a part of the O book. I wrote one that was a combination of of the two topics, the gravity in motion and the electromagnetism. But because I'm also doing my gravity in motion in the end of this year, I've had to write a separate data test that's just gravity in motion. And then I thought, well, while I'm at it, I might as well write another data test that's just electromagnetism. I don't know when people are going to be doing their unit test, whether they're going to cover other data tests, whether they're going to cover the two topics or whether they're going to cover just one topic and which one. So I've written 3 separate data tests there and then writing them to a standard that they'll get endorsed. Now I think the ones I've provided would get endorsed, but you can't tell. I don't know what endorsers are going to think of it all. I mean, many of us have done the endorsement accreditation, but it helps you, but it's not going to guarantee that your stuff's going to get endorsed. But I've tended to copy the QCAA samples for the data test, and I think I'm pretty safe. With electromagnetism, the problem I think some of you will have is, how can you modify some of those experiments? Now, I can't talk too much about that today. We haven't got time. I'll give you a few ideas. And whether you've got the equipment at school, whether it can be simple or whatever for school. Special relativity. Now, my problem is I have to do my research investigation just on special relativity, because I don't think I'll be able to get onto quantum theory before I do the IA3. So all of my claims are going to come from special relativity. Now, you might rearrange that, but I'm not so sure you could get through all 3 topics before you do research investigation. You have to really crunch it up. I don't know if that's the best. What paradoxes will be on the test, and how do they ask you, for a response to a paradox? I've written about 4 paradoxes, and they give you a couple of examples, but I've tried to write those in a way and give an answer so that the students could really just copy it. Paradoxes are so tricky, you need something simple for the kids to do. And quantum theory, there's a lot of difficult concepts in there for the kids, but I think I'll show you in a minute, we've sorted it out, something sort of learnable for them. And that standard model, it's so vague. I think I've sorted it out though, but we'll see. Now look, I think I'll just go through these next couple of slides, and then I'll show you some of those things in the book. It looks really nice when you see it in glorious colour, not just the online link you've had a look at. It's quite fantastic the way they've done it. Your black and white copy doesn't really show it. Some of the things we've written, the toolkit at the beginning, I think gives all that graphical analysis stuff. It's different to the toolkit of the first book. That was a little bit more basic. This is really just looking at what's a research investigation, what's, all that. You'll see it in your book. I've tried to give some hints about how to approach those sorts of things. Complete syllabus coverage, yeah, well, that's fine. Student workbooks, I'll talk about that in a minute. Now, probably the most important thing, this has taken me forever, practice data tests. So there's going to be at least one with the answers, all the work solutions, but I'm hoping to get the other 2 in there as well, so you can choose and cut and paste. But they'll have all the solutions. Cumulative tests. So there'll be a Unit 3 cumulative test, a Unit 4 cumulative test, a practice exam, which will be Unit 3 and 4. I've tried to make a mock external exam, but I can't call it that, because if I start calling it that and it's different to what's coming out in July, it wouldn't be fair to anyone, so I've just called it a practice exam. But in the book itself, I think there's about 1,300 questions, and they've got all the work solutions. Data tests have all got work solutions, cumulative test work solutions, and exams, all the work solutions. Plus there's a mountain of stuff. There's just so much in there. And then you'll see this stuff. These are the stimulus bits and pieces for the research investigation. So that's been good too. This is where you open up to sections. The sections are usually 4 pages, maybe 6 pages. Now, I've always tried to talk to the student, and I think that was the feedback I got from the first 3 books was about the kids would write to me and say, oh, this is really good. They'd complain about something or ask me questions. So I'd email them back, but they gave me lots of good feedback. They say it was easy to understand, and you feel like I'm talking to them, and I talk about you and we and all stuff like that. We made about 20 videos, and they're just me doing dumb things like, radioactivity and all sorts of simple things. But the feedback I've had has been amazing. Teachers have written to me saying, that's the most fantastic thing I've ever seen. We can just say to students, just watch that video. They only go for a couple of minutes before a prac, and it gives them an idea of some of the safety things and how it all fits together, and how to do some of the problems, So that's been terrific, and we're planning to do a lot more of those videos this year. So that's later in the year. The worksheets, you'll see that. You'll see that when you look at the O book. Risk assessments. I didn't do the risk assessments. They send that off to a professional company to do all the risk assessments to make sure it meets all the right things. Mandatory pracs are in the back of that book. You'll see that, and there's not many mandatory pracs. There's only 5 or 6, I think. But there's only sort of hands-on ones. Really are the inclined plane, the projectile motion, a couple of magnetism ones. This is the additional support material. The teaching notes, they were so popular with the Unit 1 and 2, where I'd write, not really a TLAP, but it's got all the objectives and so on, in right order, with things like icebreakers for the class. You know, if you're a teacher, you haven't taught quantum theory before, what do you say for the first 5 minutes of your lesson? Well, I've given a whole heap of things that I've got from, 40 years of physics teaching. So I've put a lot more effort into that. They're probably twice as big as they were for the first 2 units. Some of those chapters, there's 17 pages, and you think, oh, that's a lot to read through. Well, you don't have to read it. It's just all these little tips about ask the student this, do this. And I've tried to write them with some of the Mazzano techniques in mind, and sometimes I've mentioned what Mazzano, what I'm trying to achieve in terms of what Mazzano said. But anyway, I've told you about all the answers, spread-based learning, and yeah, this is pretty amazing. I didn't know when I did this last year how this was going to work because it was new, but I don't know if you've done it yet. If you can, when you've gone the teacher's resources section of the O book, on the digital book, you can just click the assign button, and you can assign it to one student in your class or the whole lot, because your classes are all registered with the in the O book, and that works amazingly well. I'm really pleased with that. You might remember before I said there's a number of these pain points, so I'm just going to run through some of the ideas. These slides are, there's nothing fantastic about them. I've just picked out bits and pieces from each chapter that I know are going to cause a few headaches. Partly I said because you don't know, you're trying to interpret what the syllabus content means, the words mean, and you're not quite sure. Now, what I did to make sure I was sort of familiar with what you could have on an external exam is I went through the last 10 years of IB, the International Baccalaureate papers, and the VCE, all the VCE stuff, the HSC from New South Wales and some of the South Australian stuff, and all of the past papers for the external exams in Queensland. Now, because they own the rights to, 20 years of external exams, so I'm guessing, because they own the QCAA owns the rights to them, you might see a couple of those questions appear on the external exam. But I've tried to work out from the wording what might happen based on what's common around Australia. Now, you can almost guarantee that one of the harder questions in stuff on projectile motion is going to be one where the landing point is different to the launch point. Now, it could be down here, you're throwing a rock off a cliff, or it could be up there like that. The ones I've seen over and over again is some guy playing golf and it hits a tree, and they say, how high up the tree does it hit? So be prepared. Now, I've covered that in detail, that sort of thing. In chapter 2, this is a tricky one. It's very hard. All they say about forces and vectors is, if you remember back to Unit 2, they say all the vectors are linear, so you're not dealing with any two-dimensional vectors. But in inclined planes, you're dealing with vectors in 2 dimensions, and you think, well, how can we ask that? Now, I've done some stuff with dragging a box along the ground at an angle, those sorts of things, but you can't talk about mu. There's no coefficient of friction questions. Well, they won't be on the external exam. You can do them if you like. But I haven't talked about mu, except I think in one challenge question I defined it and so on. But most of the questions of this sort are dragging a block up an incline or letting it slide down or something. But most of them, when it's dragging up, the rope is horizontal or parallel to the plane. Now, I'm almost certain they're going to think about putting one where the rope is at an angle to the horizontal or the inclined plane. So they'll have to resolve that into 2 forces and then do all the rest of it. So be prepared for something like that. Now, I asked teachers, a few of my trusted colleagues around on the discussion list, about this question, about this idea of tension in the rope. Now, this is so awful. Those of you who teach Maths C would easily do that with some simultaneous equation. But if you're trying to work out the first part's all right, what's the acceleration? But if you're trying to do tension in the string, you've got to set up an equation for that, and the tensions are equal. And I said to the QCA people, well, is that a possibility? And they said, well, anything's a possibility. It's not. No, it's not as though there's anything wrong with that question in terms of the syllabus. So I've put that in as a question and discussed how to do it. Not so much as a worked example, but when you come, there's 2 questions like this, 20, they're all 3-star questions, so they're unfamiliar and they're complex. That's what the 3 stars are meaning. And you'll see my work solution, it discusses a couple of different ways of doing it, because I got feedback from guys who are physics teachers and Maths C teachers at the time, and they were giving me different ways of doing it. So I think it'd be worth keeping that in mind. I really think for chapter 3, you know, you could substitute numbers in and do some number crunching like that. But I think that's a perfect example for a data analysis type question, not data test questions, but just giving you some data like this and say, you know, what would happen if the slotted masses were greater, what would happen, or what if the rubber stopper was greater, you know, interpret it like that. Now that's a mandatory prac, so everyone will have done it. I think it is. This would be a good multi-choice question. I think you'll see this is so common around the multi-choice around Australia. Basically, it's it's to get the velocity in terms of some of the properties. I think it's when you double something, yeah, it's above the surface. So, and this is a real problem, and I'll show you the next slide, which I deal with that. But I think for chapter 4, you're going to meet some of these multi-choice questions where they say, what will happen if you double this, if the mass of the planet doubles, or you're twice as far away, you know, and you're looking at it really and you think, is it a squared or is it a square root or something like that. This one here, I think the trick where kids will get tangled up, it's the altitude. So I've got questions where I say, well, that's the radius of the Earth plus the altitude comes to the total radius, and you've got to keep that in mind. And I think that's where multi-choice questions on a test would try and trap students into just talking about, they'd give an answer as the radius of the orbit rather than the altitude. So that's a good one. This is electrostatics. I think the question was calculate the force on C due to those 2 charges. Now this is in 2 dimensions. This would be quite a hard, 3-star sort of question. But I think I wouldn't be surprised if there's a question like that somewhere in there. I think it'd be fairly simple so that you weren't over here trying to use a cos rule or something like that. Now I've given my students some where it's, these aren't all nice and equal, where you end up with a thing at an angle here, the resultant's at an angle, and they have to use a sine rule or cos rule, or they can break it down into a whole lot of little triangles. Be worth probably doing one of those, I think. Kids seem to know, if they're doing the right maths, they seem to manage that all right. I think for chapter 7, this is fairly typical sort of question. What's the force on the wire? And they have to use their solenoid rules, and they have to know the positive charge out of there and use a hand rule, use another hand rule, work out the direction of the flux, then use Fleming's left-hand rule. I used to use a palm rule for this. Up until the first 3 books, it was the palm rule, and then we've changed over to Fleming's left and right-hand rules. That seems to be more common, so I'm teaching that at the moment, the right-hand rule, the left-hand rule for this sort of thing. I haven't got much time to do the next chapter, but remember, I'm under the old syllabus really, so but it's all the same sort of stuff. So I think you'll get questions that, a lot of graphical questions. You look through a lot of those external exams, they're full of drawings and things, and I think they like having a lot of that in it. For chapter 8, which is electromagnetism, this is one of my questions. What happens, what will you notice here if this thing's dragged away? So they have to work out the current, the polarity using a hand rule, Lenz's law on this thing, and what will happen to the current. So that's quite tricky. But there's quite, I've got a dozen or so of those sort in there. I think they're probably a likely one. Chapter 12, which is on the two quantum theory chapters. Look, I'm pretty sure that you're going to see that sort of graph somewhere. Now, what I've done over here, I've said if you learn off these three things, gradients h, intercept is f0, and the y-intercept is the work function. So I've tried to get, hopefully when kids see that, they'll learn that particular type of graph off and what the three parts mean. The intercept, the gradient, and the intercept on the x-axis, intercept on y, and what it all means. That's probably a bread and butter question from that section. So and a lot of teachers wouldn't be that familiar with this. It's all weird new stuff. And one of my pain points was a lot of this is a bit weird because it's never been done in the old syllabus. So, you have to be learning that up. But hopefully the book's done it well enough to help. Now this is, we are physics teachers, so as well as, teaching the syllabus, you want the kids to love their physics. And I keep saying in the standard model, there's no mention of colour at all there, in the syllabus. So skip this next section if you like. But I've always found over the years that my students, when they're doing these baryons made up of the different quarks, I give them questions on colours. So they have to work out not only the name of the quark, but the colour. If I give them two of the colours, they have to work out the third, all these anti-greens and stuff. But I've got a little section on that, talk about what colour force means. Mainly, I think for students who want to do a research investigation on it, that'd be a good stimulus. But I can't because it's too late in the course. And I don't think that'd make up a question as a stimulus on an external exam. I think it's a bit too far out, but it's there. I just thought I'd point out that that's a bit of fun in the book. The kids seem to like it. It takes a lesson and it's good. The tricky one, I think, people are going to have trouble with is in chapter 14 they talk about symmetry operations. But this is one of my questions I've got in chapter 14. I say, here's a symmetry operation, a crossing symmetry operation. This thing here represents a Feynman diagram for Compton scattering. I've told them all that. And then the question, or actually the question in the book is, what happens if you do another crossing symmetry operation on this one? Now all that might seem a bit weird, if you haven't read through this stuff, you think, oh good God, how am I ever going to do this stuff? I've got to teach this to kids, I don't even understand it myself, but hopefully in the book, I've led you through it, and I think the way I've written it is pretty straightforward. One of the teachers who's a bit of a whiz with his Feynman diagram said, the syllabus doesn't really show what Feynman diagrams were for. They're for scattering amplitudes, all these things are to do with scattering amplitudes and probability theory. Look, this is what I've written for the kids. I've said here, the syllabus doesn't mention any particular type of symmetry operation. And I said, if I were you, I'd learn off those 5 points by heart, right? And I've said here, there's the quote out of the syllabus. It says, describe the significance of symmetry in particle interactions. That's all they say. And you think, what the hell does that mean? What types of symmetry? So I would imagine if anything, they'd have a question that says that's the exact question they'll have. Describe the significance of symmetry in particle interactions and leave you 10 lines and you can say what you like. Well, what I'll be teaching mine is learn these things off by heart because that covers all of the possible things you could want in an answer, right? Because there is no real answer to this because the syllabus isn't that clear on it. So that's the only way I can get around that, by giving them some words to write down. And I describe each one of those, what it means. So the previous, half dozen pages talks about symmetry and what it's supposed to mean. It is really hard, but I think we've reduced it down to something that's sort of manageable for the students. Look, these are all the things you've seen before. If you've seen the Unit 1 and 3, I'll just quickly go through these. The key ideas are listed at the beginning. You've got a lot of case studies well, not a lot. In each book, each chapter, there's at least one case study, which is just a half a page. That's a good stimulus. Now, I think they're the sorts of things you could have in an external exam when they give you a stimulus and then they ask you some questions to interpret the stimulus. Challenge activities, if you remember my old blue book, it had those things called novel challenges. And people love those because they're a bit weird. And I had students from all over the place writing to me with answers. I couldn't get the answers for some of them, and they did. So they're in the book again, but I've done the answers properly this time. Study tips. I showed you a study tip before about learning off the stuff about symmetry. Worked examples. Some of them are pretty simple, and I said to my students, I'm not going to give you a worked example for that, it's so simple. And they say, no, put it in, we like it, it's really good, simple. So some of them are, quite simple, some of them get a lot harder. Then the challenges I was telling you about, this is about relativity. That's a good one about, police cars and relativity. And I'll just move on. Here's a student as a SHE topic, a 2-page topic. This is on GPS, some engaging stuff and some just the objectives. Now that comes straight out of the syllabus, but I've fleshed it out, got some questions, and the answers are all done. A lot of times you wouldn't even look at that. You'd say, well, I'm not doing a research investigation, I'm not doing this, I'll skip that. And you can skip that without upsetting anything. And this is in the workbook, stuff for the kids to fill in. These books are disposable, so the kids fill them in. And you could either not use it, or if you get it, kids can write in there, or they can do it on Excel or whatever. And you'll see that. And there's more straight out of the student workbook. All the suggested, mandatory and suggested. So I've written all the suggested ones as well. They go in there and you'll see those. And just a few bits and pieces. Okay, thank you everyone.
Thank you.
Good luck.